All right, welcome. Thanks for joining for the rest of this examples video. Again, I'm going to try and keep this relatively quick, but there's a lot of questions here. So use the properties of logs to expand the expression as a sum, difference, and or constant of multiple logs. So one thing, when I'm expanding, what I'm trying to do is make this a much longer expression. I'm not trying to simplify it. So I'm trying to sort of like break it apart. So looking at this first one, I have log base 10 of 10 to the power, or 10 times z, sorry. So right here, that is sort of in parentheses, and it's a multiplication. That means I can split it as addition. So log base 10 of 10 plus log base 10 of z. Log base 10 of 10 again says 10 to what power gives me 10, which is just 1, plus log base 10 of z. And for reference, I usually cross my z's so that it's clear to you that it's not a 2. So, this is, quote unquote, expanding. That wasn't really very well expanded. So let's do something that's a little bit more expandy. I have natural log of xy over z. So the first thing I'm going to deal with is this division. This division tells me that it's going to be the subtraction between the numerator and denominator. So I'll have the natural log of xy minus the natural log of z. Notice when I'm expanding, I'm going to have natural log be written more than once. Now, I could look at this multiplication and split that, because multiplication inside the logarithm is allowed to be split as addition. So natural log x plus natural log y minus natural log z. And, if you wanted, you can have some parentheses here, just to really be showing like this multiplication and this is in the numerator. All right, moving along, we have the natural log of the cubic root of x. So in order to simplify this, notice there's no multiplication in here, there's no division. But this cubic root of x, what you need to do is first rewrite that as an exponent. So some of us still sort of struggle with how to write roots as exponents. The type of root that you are taking will be the denominator of your exponent. And the exponent on the variable, or on the entire base, which in this case is 1, will be the numerator. So this is the same as the 1/3 power. Now, using our properties of logarithms, this 1/3 can come down as a multiplier. So this becomes 1/3 natural log x. Nothing I could do with that. I can't split it apart at all. Okay, yeah, those were all super easy. So let's do something that's like, fun. I have the natural log of the square root of x squared times x plus 2. So the first thing I'm going to do is rewrite this. This is the same as the natural log, and I'm going to use brackets just to give me a different type of parentheses, of x squared times x plus 2. The square root, so the type of root I'm taking is the second. And this whole thing is really just to the first power. Like I'm square rooting this whole thing. I wasn't, well, I'll just leave it at that. This whole thing is to the first power. Each term has its separate power, but that's different. So this 1/2 is going to come down. Sorry if that confused you. And become 1/2 the natural log of x squared times x plus 2. So now when I'm splitting this, what I can see here is that inside the logarithm, inside these brackets, I have multiplication, which allows me to split things as addition. So this becomes 1/2 the natural log of x squared plus, and this 1/2 is going to stay on this one as well, 1/2 the natural log of x plus 2. You're not really distributing the 1/2, but the 1/2 is on the natural log, and when you sort of expand it, you have to keep in mind that both of these were originally in the square root. So they both need that 1/2 power. So looking at this one, 1/2 the natural log of x squared, the 2 as an exponent can come down as a multiplier. So I have 1/2 times 2, which just gives me 1. So natural log x plus, and then this is just 1/2 the natural log of x plus 1. I'm sorry, that's a 2. I can't read my own writing. So one thing that happens particularly right here is people try to split this using like multiplication, or they try and rewrite it using multiplication. The property says nothing about addition inside the logarithm. It says something about the addition between logarithms, like the addition here between two logarithms is allowed to be written as multiplication. But addition within a logarithm cannot be split apart. So just natural log x plus 1/2 the natural log of x plus 2. All right, so that's expanding. Now getting to condensing. So this is just going the other way. I gave you the answer, the quote unquote answer, and I'm looking to write it as a single logarithm. So when I'm condensing, my final answer should just have one logarithm. So we'll start off easy. I have addition between logarithms. Addition between logarithms means I can multiply the arguments, yz, and just take the natural log of that. So natural log yz. Next, -6 log base 2 of 5x. So this -6 can become an exponent. You have to be very careful about how you write the exponent, because the -6 is on the exponent of all of the argument. So this will be log base 2 of 5x to the -6th power. What you cannot do is write it as log base 2 of 5x to the -6th power like this, because when I read this, the only thing being raised to the -6th is the x. As we're here, it's the entire 5x, because this -6 was in front of that entire logarithm. Now you might be looking at this and saying, well, this is multiplication, and I can split that as addition. And if you're thinking that, you are right, you could, but the instructions are to condense, and that would be making it longer, so it would be expanding it. This would just be our final answer here. Next, log base 3 of 5 plus log base 3 of x. I have addition between logarithms. So addition between logarithms allows me to write it as multiplication, log base 3 of 5x. And then a fun one, the natural log of x minus the natural log of 3 plus the natural log of x plus 1. So first, I'm going to start on my inner parentheses over here. I can't do anything to this, x plus 1. Cool, great. I don't know what x is. So over here, I have addition between logarithms. Addition between logarithms can be rewritten as multiplication. So this is the natural log of 3 times x plus 1. Then I have this subtraction. This subtraction can be written as division. So I'm going to have x over 3x plus 1. And it's the natural log of this entire thing. All right, good. Yeah, that was fun. So moving on, find the exact value of each logarithm. So I have log base 6 of the 4th root of 6. So you're thinking like 6 to what power gives me the 4th root of 6? And we're going to use some of our properties to rewrite this. So first, rewriting this, it becomes a log base 6 of 6 to the what power? Well, the degree of 6 is 1. But because it's the 4th root, that becomes the denominator of the exponent. Using my properties, I can bring down this 1/4. So it becomes 1/4 log base 6 of 6. Log base 6 of 6, you can either think of it as this cancels, or more importantly, this is 6 to some power gives me 6. So this is just 1. And 1/4 times 1 is 1/4. Log base 2 of -8. So what I want to do, because I'm trying to use some properties here, not using that circular idea, log base 2 to the -8. Thinking about what a logarithm means, this is 2 to some power gives me -8. Now, we can deal with ways of rewriting this, but we're going to have an issue. This right here is not part of our domain. Our domain of a logarithm is x is greater than 0. That is not greater than 0. So it's not in my domain and it does not exist. And if you think about that circular motion, I just said we weren't going to, but let's take a step back. We're going to think about it. 2 to some power gives me -8. There is no power on 2 that would give me -8. And if you're thinking -3, you're wrong, because 2 to the -3 power, the negative tells me that this just becomes 1 over 2 cubed, which is 1/8. So that's not going to give me a negative number. Remember, our domain on a logarithm is that it must be greater than 0. So this would just be no solution. All right, fun. Log base 4 of 2 plus log base 4 of 32. So if I'm talking about splitting some of this, I can't really split 2, so I'll leave that. Log base 4 of 2 plus log base 4 of, I can rewrite 32 as something like 16 times 2. Rewriting it as 16 times 2, I can now split this as addition. So log base 4 of 2, log base 4 of 16, and another log base 4 of 2. You can combine those log base 4s of 2, but I want to talk about what that means. Log base 4 of 2 means 4 to some power gives me 2. 4 to some power gives me 2. Well, what relationship does 4 and 2 have? The square root of 4 gives me 2, and the square root is the 1/2 power. So when I say log base 4 of 2, the answer to that is just 1/2, because 4 to the 1/2 power gives me 2, plus 4 to what power gives me 16, the second, plus 4 to what power gives me 2, 1/2. So this is just 3. And again, I tried to avoid using that circular motion just to show you how those properties can pan out. All right, last, given that natural log A is equal to 3, natural log B is equal to -2, and natural log C is equal to 5, find the exact value of. So here's what people do with this problem. They put in 3, -2, and 5 for A, C, and B, because they see, well, A is equal to 3, B is equal to -2, and C is equal to 5. But it's the natural log of A that is equal to 3. And right now, I don't have natural log A. I can't substitute that. What I need to do is expand this so that I can get natural log A, natural log B, and natural log C written exactly like that. So if I'm going to do an expansion on this, first, I could look at this division. So I'm going to look at natural log of A squared C cubed minus natural log B to the 1/2. Division inside a logarithm can be rewritten as subtraction. Multiplication can be rewritten, so I'll have natural log A squared as addition. Natural log C cubed minus natural log B to the 1/2. This is the next step where people usually make a mistake, because at this point, that's sometimes when they substitute and they say, okay, so I'm going to have the natural log of A, which is 3, and then squared. But the problem is you cannot still substitute in, because this is the natural log of A squared, not the natural log of just A. Again, we are not substituting in A, B, and C. We're substituting in the natural log of them. So all of these exponents need to come down as multipliers first. So 2 natural log A plus 3 natural log C minus 1/2 natural log B. At this point, natural log A, natural log C, natural log B are alone, so I can replace or substitute. 2 times 3 plus 3 times 5 minus 1/2 times -2. 2 times 3 is 6 plus 15 plus 1 equals 22. So just be careful with that question. This is definitely one that you don't do as much practice on, but you definitely see kids make mistakes. And I'll tell you again, those 2 mistakes are people substituting in right away, which is just super wrong. Come on, that would be way too easy of a question. And then substituting at this point would be the other mistake. You have to make sure that you bring down those exponents first. All right, that's it for the examples. I don't know how long it took because it doesn't tell me, but good luck. Get started on section 3.3. It's not too bad. Make sure you practice those logarithms, especially the graphing.